Welcome to solverfy.
In this question, we're trying to figure out the relative values of ZEF for atoms A and B. So ZEFF is going to be, that is the effective nuclear charge. So what that is that is the net positive charge experienced by an electron in a polyelectronic atom. So it's really the basically what it would be is if we have the nucleus of an atom here, and then we have orbitals surrounding it, and then we have a valence electron here. It is the effective nuclear charge, so the charge from the positively charged nucleus that is experienced by this valence electron, and it affects the electrostatic forces between the nucleus and the electron. So we're given the wave function of the molecular orbital in terms of the wave functions of the atoms A and B, and we're looking at the heteronuclear molecule AB. So basically atom A and B combine to make a compound AB. So the coefficients in this are the weights of the contributions of the atomic orbitals of A and B to the overall molecular orbital of AB. So you can see here that that means that A is contributing more. So then a wave function is a mathematical function that relates the location of an electron at a given point in space to the amplitude of its wave and its energy. So that's really just saying that the wave function is kind of like showing the probability of the position of the electron, and it relates it to its energy. So in this formula, you can see that atom A contributes more to the wave function of the molecular orbital than atom B. So if we look at the two atoms, A is in a later group of the periodic table than B. And the reason would just be because it's multiplied by the larger number. So therefore, that means the effective nuclear charge of A is greater than B because it has the greater atomic mass. So the one that has a greater atomic mass should have the greater effective nuclear charge. So we would say that effective nuclear charge of A is greater than effective nuclear charge of B.